Hi guys, I hope you had a great Easter break. We're going to do 6.5, but I'm splitting it into 2 days. So that's what we'll be doing this week is just 6.5. Today we will do the operations with functions, and I guess I don't think this isn't really new, just how it's written is new. And then day 2 of this will be a little bit more confusing, but it's really not that bad. So I think you guys will get it just fine. Let's start with the notation for function operations. Okay, and all it is it's just showing you that if you're going to add two functions, f of x and g of x, that's just their names. If you're going to add them, it's going to look like this: f plus g of x. Subtracting will look like f minus g of x. So in this case, your f function will go first. If it said g minus f of x, then the g function will go first. Here's multiplying, f times g, and then division is f divided by g. And again, this matters which is on top. So let's just practice a couple of these real quick. Like I said, it's nothing really new. It's just the way that the notation is just probably new. So we're going to find these functions added and these functions subtracted. So I have my f of x here and my g of x here, and I'm going to add them together. So to add these together, I don't know why my stuff's so crooked today. I'm going to literally just put in the two functions, my g of x here, my f of x here, and it's just adding, so I didn't need parentheses, and now I'm just going to combine my like terms. So I have a 3x and a 6x, 9x, negative 1, and a positive 2 is a positive 1. Now I'm going to give myself some more space. And then I will subtract the two, and the f function goes first. So this time I will use parentheses because it's subtracting. And then I'll put in my g function. And in order to drop the parentheses, I will need to distribute this negative. So I will rewrite that as 4x squared plus 3x minus 1 minus 6x minus 2. And then I'll go ahead and combine my like terms now. So I have 4x squared. My 3x and negative 3x is, or my 3x and negative 6x is negative 3x. And negative 1 and negative 2 is negative 3. And that is my f minus g of x. We'll do one of adding and one of dividing as well. Okay, sorry for that interruption. My husband called, and apparently it comes in on my computer and it's really loud and annoying, and I had to pause this, and I was whatever. Life is good. We're moving on. We are going to multiply and divide now. And so the only thing is, when you divide these functions, then we have to note domain restrictions. So we just have to say the domain. Let's take a look at this f of x and this g of x, and let's multiply. So we have f times g of x. So I will write this out: 6x squared minus x minus 12 times 2x minus 3. And of course I need to distribute or multiply or kind of like boil through everything. And we've done this in previous chapters. So 12x to the third minus 18x squared minus 2x squared plus 3x minus 24x plus 36. Okay, which gives me 12x cubed minus 20x squared, I'm just combining my like terms, minus 21x and plus 36. That would be f times g of x. I will do the division next. So when I have f divided by g of x, all I do is I put the first function as the numerator and the second one as the denominator. And I'm actually going to factor this top and see if I can reduce this at all. So the top, it looks like we have a quadratic trinomial with the a not being 1, so I'm going to use the swing method here. So I have x squared minus x minus 72, and I will groupie that. Looks like I could do x minus 9 and x plus 8 because negative 9 times 8 is negative 72, and negative 9 plus 8 is negative 1. And then I have to remember to divide by my 6, which gives me x minus 3 over 2 and x plus 4 over 3. This is all still my numerator. I'm just getting all crazy. So I'm going to rewrite that as 2x minus 3 and 3x plus 4. If you remember, you can just bring this little denominator back up. And then I still have my original denominator of 2x minus 3. So that means I can cancel those factors out. So I'm left with just 3x plus 4. I do need to write my domain. So x cannot equal, and I have to go with the original, x cannot equal whatever this is set equal to 0. So that is 3 over 2. And in case you forgot how to do that, yeah, you just set that equal to 0, 2x minus 3 equals 0, and solve. Add my 3, divide by 2. So x equals 3 over 2. That's the number that would make this denominator 0. We can't have it be 0, so I'm just going to write it like this. Okay, so this part was nothing really new. At least the operation doing it is not new, just the notation. We go on to a little bit of composition of functions, and we'll spend more time with the algebra in this next time, but we're going to just introduce this a little bit right now. So the composition of functions is a function operation, just like adding, subtracting, multiplying, dividing, but it uses the output from one function as the input for a second function. And the notation for that, you will probably most likely see it as this, f of g of x. But you may also see this, and this is f composed of g. Or you can still say f of g of x. I always pretty much say f of g of x. A lot of the kids used to say like fog, or if you were doing g of f of x, that could be written like goff. And that's just like an open circle, kind of like a degree sign. It's not a 0, it's not a dot, it's definitely not a multiplication symbol, but it just represents which functions are what. And I prefer this way because it's easier to see what goes into which function. That's just my opinion. You will see it both ways in your life, I'm sure. So let's look at 3a here. It says that we're given f of x is 2 raised to the power of x, g of x is 7 minus x, and we need to find g of f of 4 and f of g of 4. So, two separate things. Let's take a look at g of f of 4. Okay, that's totally a 4. So what that means is you start with the inside here and look at f of 4. We're going to find what f of 4 is, and whatever that is, we're going to put into g. So let's start with the f of 4. So here's my f function. So I'm going to put in a 4. So I have 2 to the 4th, which is 16. So f of 4 is 16. So now I have g of 16. So I'm going to put 16 in for the x in the g function, and I get -9. Oh, it did this stupid thing again. Okay, so g of f of 4 is -9. That's how I do it anyways. I start with the inside, I put it into the f, and then whatever I get there, I put it into the g. Let's take a look at this other one. So this time I'm going to do f of g of 4. So that means I have to put the 4 inside the g function first, and then whatever I get, I put into the f function. So my g function is this one. So I'll put a 4 in for x there. 7 minus 4 is 3. So I get 3 for this stuff. So then f of 3, I put in to the f function. 2 to the power of 3 is 8. Okay? So depending on which one you have first, it makes a big difference. G of f of 4 is -9. F of g of 4 is 8. Let's do another one. So here I have two functions. F of x is 2x minus 3, and g of x is x squared. So I'm going to find f of g of 3 and g of f of 3. So f of g of 3, I'm going to put the 3 in the g function first for x. So I have 3 squared. So I have 9. So now I need to find f of 9. 2 times 9 is 18, minus 3 is 15. And that's your answer for that one. Then we will find g of f of 3. So now I will put 3 in the f function first. So I have 2 times 3 minus 3, so I get 6 minus 3, so I get 3. And then I have g of 3. So I put it into my g function, and I get 9. So f of g of 3 is 15, g of f of 3 is 9.